video, we're going to go over number 2. All right, this is a problem that you'll kind of recognize a little bit of the work that we did if you remember from last week. Do you guys remember the athletes A, B, and C? And we looked at their, I think it was 100-meter dash. It was their like shot put and their long jump or whatever. Remember doing that? Some of that will be happening here in this AP problem. Right? This is a real AP question from many years ago. So in the first part A, and I'll do some writing on this. I did a poor job of giving you space to write. So if you want to write below at the bottom, that's fine too, or just take little notes. The key to this, like the actual rubric solution, is already on Google Classroom, so you can see what the like College Board is expecting for like a full solution. So in the first one, it says that they're running a 40-yard dash, all right, and they're giving us the mean, so the average, they're giving us the standard deviation and the minimum, okay? It says based on basically all 3 of these statistics, is it reasonable to believe that all of the running times, so if I knew all of the running times at wherever we are, is it the distribution approximately normal? So real quick, if you go back to last week, right, if I draw a normal model, right, what's right down the middle? The mean, right, my mu. And how many lines did I draw to the right and to the left? 3, right? So this is 1 standard deviation, 2, and then 3 standard deviations above. 1, 2, 3 standard deviations below the mean. Basically referring to that rule that I tried to teach you guys last week called the 68, 95, 99.7 rule that states that 68% of your data values will fall between 1 standard deviation below and above. 95% of all your data values should fall between 2 standard deviations above and below. And then 99.7%, which is essentially everything, but not all, but almost, will fall between 3 standard deviations above or below. So if this is going to be normal, right, quote unquote normal, I would expect my minimum to be roughly where when I look at the normal model. Where should I expect the minimum to be around? How many standard deviations below the mean am I expecting? 3. So if I standardize this, right, I have a mean, I have a standard deviation, I have a data value. If I standardize that data value, finding a z-score, then that should give me some insight into if this is normal or not. So let's do it. Do you guys remember the formula? Z equals y minus mu, or mean, over standard deviation, or sigma. Right? Am I really concerned if you did y bar and s? No, not really. Technically, this is from actual players who probably should use y bar and s. But the key thing is, do you know that it's the data value minus the mean over the standard deviation? That's the thing. I'm not going to be giving you that formula. You've got to know it. All right, so let's plug it in. So we have 4.4 is the minimum, minus 4.6 is the mean, over 0.15. Use your calculator. So we have 4.4 minus 4.6 divided by 0.15. So our z-score for this minimum 40-yard dash time is negative 1.3 repeating. All right? Now, if this was normal, we said, what are we expecting to see for that z-score? What am I hoping to see if I want to think that this could be normal? No, not 0, right? My minimum should be how many standard deviations to the left of the mean. I'm expecting my minimum to be around here, right? And how many standard deviations is that? 1, 2, 3. So I'm really expecting this to be negative 3 or approaching negative 3. Is negative 1.3 repeating approaching negative 3? No, it's not. So based on that, do I think that this distribution is normal? I do not. So no, because the minimum wasn't near 3 standard deviations below the mean.
Oh wait, so like 100% of the data could be between the first 2, but that doesn't mean But that would mean it's not normal.
So if it's going to be approximately normal, we're expecting 68% of the data to be between 1 and -1 for standard deviations, 95% for 2 above and below, and then 99.7% of the data to be between 3 and -3. So if you're telling me 100% of the data is between 2 and -2, I don't think that's normal either. I think you'd have to have more in past 2. Not far off, right? Because 95 and 100 is close. Yes?
When do you use the second bars blah, blah, blah?
Not on this problem, right?
Yeah,
It's
like, how do we know when to use it?
when it asks you to either find, like if I had a problem that said, what is the likelihood that, or the percentage of players who run a time greater than 4.7 seconds, then I would do that. Or if it said, what is the time associated with the 5% for the slowest 5% of players, then I would use the inverse norm that's in there. Right? This question is not asking you to do any real calculator stuff besides, basic algebra. Is everybody okay on A? Okay, let's go to B. So letter B is giving us some information about strength or the amount of weight that is lifted. And it gives us a new mean, right? You see it gives us a new mean of 310 and a new standard deviation for 25 pounds. Calculate and interpret the z-score for a player in this position who can lift a weight of 370 pounds. So I'm going to use that same formula. This time I'll use y bar and s. Again, I'm not that concerned about it since we're talking about actual data values here. Right? This player can lift 370 pounds. So 370 minus 310 over 25. So let's see what that z-score is. Did you get it, David? 2 point something? That's helpful. 2.4. 2.4. Okay, now what happens on these types of questions on the AP exam is students will not continue writing. They'll just say the z-score is 2.4. Did we answer the question, calculate and interpret the z-score for this player? No, what have we done? We've calculated. So that's one of the things I need to teach you between now and May is how to just give a full, complete answer. So right now we've calculated the z-score of 2.4. Now we need to interpret it, okay? So here's how I interpret it. This player's ability to lift weight is 2.4 standard deviations above the mean. All right, so anytime you're asked to interpret a z-score, it's essentially asking you to say how many standard deviations above or below the mean this value is.
Wait, so z-score is always going to be like...
I don't want to say they're always going to be between -3 and 3, but I'm expecting them to be between -3 and 3. If it's not, if you tell me like, I don't know what it would take, maybe 400. Let's say the player that has a z-score for a player that lifts 400 pounds is 4. Just making this up. We can probably figure it out. That would tell me that player's weight or ability to lift that weight is unusual. Unusually strong. All right. Any questions? Yeah.
Z-score would always be somewhere around, talking about the standard deviation.
Okay, so we can say always with that. Z-score is always standard deviations. If you are given a z-score, whatever the number is, 1, 2, 3, 4, -1, 2, -2.7, whatever it is, that's always how many standard deviations above or below the average. Always. Right? So like when my children take their standardized tests, I want them to be very high z-scores. How many standard deviations are their scores above the mean? Right? Positive high z-scores. Right? Absolutely. So that's what a lot of students are like, oh, zero is, are you been told for a long time in math that 0 is bad or 0 means nothing? But if your z-score is 0, that means you performed exactly as the average was. So that's actually not about you're average. Okay?
Don't call me average. That's just...
Nice. You made it on the recording. Okay. Letter C. Letter C, we've got two players, player A and player B, and I think you'll find this one to be very similar to that like different event thing that we did a week ago, actually. All right, so we need to pick one of these players to select for our team. So we're evaluating talent for a draft of some type. In this case, talking about running and strength. So I always just go to football. We're starting football now anyway. Let's standardize each of these players' performances and then analyze those Z-scores, okay? So I'm going to do player A first, which is, what was it, the 40-yard dash? So that's going to be Z equals, player A ran it in 4.42 seconds, minus, what was the average? 4.6. I'm just using the box or the table from the first one. And the standard deviation was 0.15. So let's find that Z-score. Negative 1.2. Now, notice, this is kind of like we talked about last week. That's a negative Z-score, so your mind is thinking that's like not good, right? But remember, this is running, right? Time. So actually, when it says negative 1.2, they actually are 1.2 standard deviations faster than the average. So that's actually a good thing to be negative in the dash. Okay, and then this is weight lifted, which is 370. Is this one that we just did, 370? Yeah, we just did 370. We just calculated this one. And what was that, 2.4? Okay, I'll do player B. So they ran the 40-yard dash in 4.57 seconds. So still faster than the average, but you can see that definitely closer to the mean. So negative 0.2. And then they lifted 5 more pounds than player A, which results in so only resulted in a 0.2 increase in terms of standard deviations stronger. All right, so try to catch up on all of the calculations. And again, if you got questions on how I calculate things, please let me know. But when I analyze this, when I look at this, my first thought or my first thing my eyes go to is that, bless you, for the weight that's lifted, they're relatively the same, right? Obviously, player B is stronger, or at least on that, whatever a day that they did this, like they were able to lift 5 more pounds, whatever the bench, whatever they're doing, all right? But when I look at their speed, right, when I look at the speed that they ran, this player B compared to player A is 1 standard deviation slower. So even though player B is stronger, they're only a little bit stronger, but they're a whole standard deviation slower. So if I'm going to choose a player for our team, I'm going to choose player A. Because even though they weren't able to lift as much weight, only 5 pounds less, that's not that much, but they were a lot faster, and I can give you an actual value. They were 1 standard deviation faster than player B. So I'd rather take someone who has that in terms of the speed, even if they're a little bit weaker. Is everyone okay with that? Yeah? We feel good? Okay, cross your fingers, okay?